Hi, everybody. Mr. Wyatt again. And today we're looking at topic 7.5, section 3. We're looking at special pairs of angles, and we're going to spend a couple of days in section 3. So I have a 3A today. We'll look at 3B tomorrow, where we'll be talking about parallel lines and something called transversals, but that'll be tomorrow. All right, so special pairs of angles. Here are some more terms for us to learn. That's one thing about this topic 7.5 is we have a lot of vocabulary, a lot of words to learn. Well, the first two terms you need to know are complementary and supplementary angles. Complementary angles are angles which total 90 degrees. Okay, angles that total 90 degrees. So if I have a 51-degree angle and a 39-degree angle, if you add those together, 51 plus 39, you will find that it equals 90 degrees. Normally, you would see complementary angles um, that combine together to form a right angle. Okay, that's where you normally would see your 90 degrees. So angles 1 and 2 are complementary angles. Okay, so imagine this was 51 degrees and this was 39 degrees. Well, they're complementary angles because they total that 90 degrees that you see right here. Supplementary angles, on the other hand, are a little bit different because they are angles which total 180 degrees. So you see this angle here that's 65 degrees, this angle that's 115 degrees. If you add those together, they total 180 degrees. All right, usually though, you will see like a straight angle. Here's your straight angle right here, and it's been split here by this ray, splitting it into two separate angles. Angle 3 and angle 4 are supplementary angles because if you put them together, they total 180 degrees here, which is half the distance around a larger circle. I didn't draw that very neatly, but those are supplementary angles. Okay, so if this angle 3 was 115 degrees, then angle 4 would have to be 65 degrees for them to add up to 180 degrees combined. So complementary angles, supplementary angles. How do you remember which is which? Because both words are pretty similar. I always look at the C in complementary, and I don't know, maybe this sounds weird to you, but I think that C is closer to looking like a 90-degree angle. I could almost put like complementary. You're thinking, well, that's not a C anymore. That's an L. Well, you're right. But that's what I've always done to help me remember one from the other. But complementary angles are the ones that total 90 degrees. Supplementary angles, you have a straight angle here, which starts with the letter S. Supplementary starts with an S. That straight angle there starts with an S as well. Okay, if that helps. All right, so find the complement and the supplement of the following angles. We'll just do a couple of these. If I have a 25-degree angle, the complement would be the angle that together with 25 degrees would total 90. So if I take 90 minus 25, well, that's 65 degrees. I guess the complement would be 65 degrees. If I wanted to find the supplement of a 25-degree angle, now I need the angle that combined with the 25-degree angle will be 180 degrees. So I could take 180 degrees and subtract 25 degrees. And that's 155 degrees. So the supplement of a 25-degree angle would be 155 degrees. The complement of a 25-degree angle would be 65 degrees. And again, to find the complement, or the angle that's complementary to the 25-degree angle, you subtract from 90. To find the supplement, or the angle that's supplementary to that angle, you would subtract from 180 degrees. Okay? I don't really like looking at them just straight out like this. I kind of like looking at them in context, like when you have an angle drawn or a straight angle that's split. It's just more useful. Like this. Find the missing angle measures. Here I have a 58-degree angle. That's this angle right here. is 58 degrees. Could you tell me how to find the measurement of angle X? Well, together they form this right angle here, which is 90 degrees. So angle X and this angle that's 58 degrees are complementary angles. They total 90 degrees. So if you want to find the measurement of angle X, then you can take 90 degrees and you can subtract 58 degrees. And when you subtract that, you'll get 32 degrees. Here I can make this 9 into an 8. This becomes 10 then. 10 minus 8 is 2. 8 minus 5 is 3. So we find out angle X here has to be 32 degrees. And you can check your math on that. Just take 58 plus 32. And what should it equal if we add those together? Well, it should equal 90 degrees. 8 plus 2 is 10, carry the 1, 5 and 1 is 6, plus 3 is 9. There's your 90 degrees right there. So all I had to do was subtract this 58 degree measurement from 90 degrees to find out what angle X has for a measurement. Is that pretty easy? That's not too bad, is it? Let's look at this next example. Here I have angle Y. I want to know what's the measurement of angle Y. Well, right next to it, I have an angle that's 146 degrees. Well, these are supplementary angles because angle Y combined with the 146 degree angle totals 180 degrees, half of a circle. So if I take 180 and then subtract 146, the difference would have to be the measurement of angle Y. So I'll go ahead and make this 8 into a 7, which makes this 0, 10. 10 minus 6 is 4, 7 minus 4 is 3, 1 minus 1 is 0. So we have 34. Angle Y has to be equal to 34 degrees. And you can check your math on that too by adding 146 plus 34. If we did everything right, when we add these together, they should total that 180 degrees since they are supplementary angles. 6 plus 4 is 10, carry the 1. 4 and 1 is 5, plus 3 is 8. And then I have the 1 over there. It does add up to 180 degrees. And now if you look at this figure, I have a pair of intersecting lines, and I know this angle here is 37 degrees. Can I find any of the other angle measurements then? Actually, look at angle A. Angle A is right next to this 37 degree angle. Together, the 37 degree angle and angle A are adding up to 180 degrees. They complete this one side of this line right here. So you could say these two angles are supplementary angles. So they have to total 180 degrees. So if I subtract 37 from 180, that'll give me the measurement of angle A. So let's make this 8 into a 7. This becomes 10. 10 minus 7 is 3. 7 minus 3 is 4. And I have that 1 out in front. So angle A here is 143 degrees. Now I could find angle B then the same way. Once I know angle A is 143 degrees, how would you find angle B? Would you do the same thing? Because here, if you look at this line, angles A and B are supplementary angles. So they have to total 180. Now, if I take 180 and I subtract 143, isn't that just going to give me 37? Take a look here. This becomes 7. Make this 10. 10 minus 3 is 7. 7 minus 4 is 3. 1 minus 1 is 0. So angle B is 37 degrees. And I could do the same thing with angle C here. but I think you might know what angle C is going to be. We have the 37-degree angle here, and we have angle C here. Together, they form this 180-degree angle right over here. They're supplementary angles. So again, you could take 180 and subtract 37 like we did here, and we find out angle C is 143 degrees. So what's kind of neat here is when you have these intersecting lines that are forming these four angles, when you look at these four angles, angles A, B, C, and D, they are all either 143 degrees, the obtuse angles are, or they're 37 degrees, the acute angles. And I'm also noticing the angles that are across from each other have the same measurement. Here the 37s are across from each other. Here the 143s are across from each other. And there is a special term for those angles that are right across from each other. Those are known as vertical angles. Angle A and angle C are vertical angles. Also, angle B and angle D are vertical angles. They're straight across from each other. Now, this term vertical can confuse some people because we've always been taught vertical means up, down, doesn't it? But A and C, angles A and C, are they up, down from each other? Well, no, they're left, right from each other. So we have to look a little closer at that word vertical. The root word here is vertex. This comes from the word vertex. We have a vertex right here, which is where all of our angles has its beginning. You know, you have angle B, angle C, angle D, angle A. This is the vertex. Vertical angles just means angles that share the same vertex, but are mirror images of each other, okay? It's like we have a spotlight right here and it's shining light in these two opposite directions here, okay? They share the same vertex. That's why they're called vertical angles, because they share the same vertex, not because they're up, down. Angle B and angle D are up and down, but A and C are left, right. It doesn't mean up, down. It just means they share the same vertex and they go in opposite directions, like they're mirror images of each other. Okay, and what's cool about vertical angles is they are congruent, meaning they have the same measurement. So angle A is congruent to angle C. The congruent symbol is an equal sign with a little squiggle over the top of it. Okay, that means congruent, which means they have the same measurement. So if you know the measurement of angle A is, for example, 40 degrees, then angle C also has to be 40 degrees. Okay, and angle B is congruent to angle D. Why? Because they are vertical angles. They share the same vertex, they're mirror images. They even look like they're the same measurement. They would both be 140 degrees. How do I know that? Well, I know that because the angles that are next to each other are supplementary angles. They have to total 180 degrees. And 40 plus 140 does equal 180. Okay, so vertical angles, they share the same vertex and they're mirror images of each other, those two angles. And they are always congruent to each other. Now, the last term to discuss today is adjacent angles. Adjacent angles are angles that are right next to each other. They share a common side, like angle 1 here and angle 2 here share this one particular side, this ray here, in common. They don't overlap. They're right next to each other. Now, are they congruent? Well, they might be, but usually they're not. Okay? Now, if you have adjacent angles formed by intersecting lines, they are supplementary, meaning they total 180 degrees. Here I have a line intersecting another line. Angles A and B, for example, are adjacent, meaning they're right next to each other. And they're supplementary. See how they total 180 degrees? Angle A and D are adjacent angles. They're right next to each other. See how they're supplementary? They total 180 degrees. Are A and C, are those two angles adjacent? No, they're vertical. So they're congruent. Angle A and angle C have the same measurement. Okay? I hope